Well, hello. Well, hello. How's everybody doing? Welcome to another math video, you math rock and roll stars. Today we're going to do some work with the area and perimeter of triangles. We're going to be diving into the three-sided world. Should be a good time. Hey, how do you find a princess? You follow the footprints. Footprints? Footprints? Come on, that's good. You know you love that one. That was a good one. Okay, so the target for the day, we're going to develop the formula for determining the area of triangles. So we're going to make sure, instead of just seeing a formula and plugging in some numbers, we're going to make sure we understand where that comes from, okay? So that's the main focus of what we're working on today, and we're going to be able to use that when we solve problems in context. All right, so let's do a little vocab, okay? Speaking of area and perimeter, let's just freshen up our skills. The perimeter is the distance around the outside of a shape. And the way we calculate it is just simply adding up all the sides. Okay, so you have some examples of a rectangle, of a triangle, of a quadrilateral. And so all you're seeing is like they're all labeled by the sides. And to solve them, we just add them up. It's one of the easier, I always think of perimeter as a fence. If I'm going to put a fence around something, I need to buy the right amount of fence. And how do I know how much fence I need? I measure the outside of whatever I'm trying to fence in and buy that fence. Perimeter, the distance around the outside of a shape. Next is area. So it's the size a surface takes up. So you think about the carpet if you're sitting in a room right now where there's carpet, the area of the floor is how much carpet does it take to cover the floor. And we measure that in square units. And one way to kind of think about it is if you've ever been in a room that has tile on the floor, or like some cafeterias have this, they have a bunch of square tiles. Well, they had to figure out how many square tiles they needed to cover the floor. So that would be the area of the floor. And so I got some shapes on here for you to look at, and the reason I did it this way is I just want you to see all the ways that you can find area by figuring out how many square units will cover that particular area. Okay, so let's start working on finding the area of the triangle. It's the harder of the two because perimeter, remember, we're just adding the outside. So the area of a triangle. Now, before you get to triangles, most of us have done work with rectangles, and we have used area when we've been dealing with rectangles. And so remember, the area is the number of square units that cover a shape. So if we know the length of a rectangle, so here's a rectangle, let's say it's 4 feet long. Okay, and what we do is we break that into 4 columns. So we have 4 columns wide, and then if we know the width of it is 2 feet, okay, and so we break that into 2 rows. So we basically have 4 rows of 2, or 4 columns of 2, or 2 rows of 4. When we know that, we can figure out the area, how many square units it takes to cover. We can just simply say there are 8. And we can look at it and count it, but also what we do is we use the area formula, which was length times width. We take our rows, and how many is in each row? Well, there's whoops. We take our rows, and we say that there is 1, 2, 3, 4 squares in one row, and the other row would have 4 more. 1, 2, 3, 4. And 4 rows of 2 equals 8, right? So length times width, and that's how we develop that formula. Okay, so now what we want to do is think about how can we translate that. All right, so here's our rectangle. And think about this. All right, so what happens when you draw a diagonal line in a rectangle? So we just drew a diagonal line all the way from one side, one corner to the other. What happens? Well, a diagonal cuts this rectangle in half. It shows us 2 triangles. So here's a triangle and here's a triangle. And they are equal in size, right? It cuts them in half. We could rotate them and turn them around. And if you did this on a piece of paper and you cut a piece of paper diagonal from one corner to the other, you could flip the paper around and rotate it around, and you would see that those 2 triangles are exactly the same shape. So in other words, we cut the rectangle in half to form 2 equal triangles. Okay, so here's our rectangle, 2 feet by 4 feet. We drew a diagonal in it to make it 2 equal triangles. So if we want to find the area of one of those, let's just use what we know about the formula for rectangles to get to that point. All right, so here is our triangle now. Did the length of it change down here? No, it's still 4. Did the height of it change, or the width? No, it's still 2. So it's 2 by 4. Okay. So if a triangle is simply 1/2 of the rectangle, then doesn't it make sense just to say the triangle's area is exactly 1/2 of the rectangle's area. So again, if our rectangle was 2 by 4, we would have said 2 times 4 is 8. So the formula for rectangle is length times width. That means the area of the rectangle was 8. So let's just cut that in half. What's the area of the triangle? Well, it's 4 because it's half of the area of that full rectangle. We just cut it in half. Okay? So it's pretty simple when you think about it that way. So let's do some lingo changes though, because when you see your formula, they kind of change a couple of the words. So a rectangular's formula is length times width. Cool. It makes sense when you're describing a triangle. How long is a triangle? How wide is it? Or I'm sorry, rectangle. How long is it? How wide is it? But when we're dealing with triangles, we used, instead of length and width, we change it to base and height. So here's our triangle, okay? This would be the base down here, and this would be the height. And that's a right triangle. If you don't know what a right triangle is, it's simply a triangle that is formed with a right angle in one corner. That corner right there is 90 degrees, which makes it a right triangle. And that's how we know, like, when we did our rectangle, when we did the rectangle, sorry, the screen is shaking quite a bit today. When we did a rectangle, it was cutting a rectangle in half with a diagonal. It made a right triangle. But sometimes we have triangles that are not right triangles. It's still the same thing, right? The formula for triangles is 1/2 base times height, right? So we formed, because we know that a rectangle is base times height and a triangle is half of a rectangle, we know our formula is half of base times height. So the base can literally be any side of the triangle, but the height sometimes is a bit more tricky. Let's look at those triangles again. So here we got this guy, and let's call the bottom of the base. I can call any side the base, but I'm going to call the bottom right now the base because that just makes more sense, right? You're setting it down. Now, for the height, we have to find the height of the triangle. So the base is dealing with that side of the triangle, right? And so to find the height, we always look for the angle on the opposite side of the base, which would be right there. Okay, and then we draw a line straight down from there, because that's how we'd measure height, right? If you were trying to figure out how tall TallTal is, you wouldn't like measure from the height of my top of my head over to the corner of the room, would you? You would measure straight down. So that's how we solve the height. I mean, that's how we label the height. We measure straight down. So not too hard, right? All right, so that would be the height. So let's look at a couple. All right, so where's the base? Pick any side. I chose that one. Where's the height? You find the opposite angle. You draw a line straight down, and there's your height. Simple, right? Same with this one. There's the base. There's the top. Straight down. There's the height. Whoa, this is a weird looking triangle. What are we going to do with this? Well, let's go ahead and label the base. What is the angle that's opposite of the base? It's right up there. So now it just seems different, but it's the same philosophy, right? Just go ahead and figure yourself an imaginary line and measure straight down. All right, from there, and that would be our height. And all you got to do when you're solving the area of a triangle is like, let's make sure we know where the base is, what is the height, and then, yeah, we then go back to plugging it into the formula. So let's look at this one right here. So the base would be here because they've given us the height here, which is telling us that is the opposite angle. So the opposite of that angle has to be the base. So our base is 4, our height is 2.5, and then either on a piece of paper, you calculate this, or you type it into a calculator if you're allowed to, and you say, what is 1/2 times 4 times 2.5? And it gives us 5 as our answer. 5 is our answer. When you type that in a calculator, you'll see. So the area of that triangle is 5. And if it was inches, it would be 5 inches squared. Okay, so here's our next one. Okay, this is that other one we had. So where is our height? Our height is 4.5, right? Because we find where it's labeled in there. And this would have been the top of our height. So which of these is going to be the base? It's going to be that guy because it's opposite the top of the triangle. So 12 is our base. 4.5 is our height. And we multiply 1/2 times 12 times 4.5. And we get 27. Killing it. Here's that tricky one. Okay. So here is our triangle. And we're knowing that this is the height right here, right? So where's the opposite angle of that? Or opposite side of that? It's right here. So there's our base. Here is our height. We plug those numbers in, right? And then we go to our calculator and say, what is 1/2 times 5.5 times 3? And we get 8.25. And that's how you solve area of a triangle. Pretty groovy, huh? Okay, so now perimeter. Way simpler. Okay, perimeter just means side plus side plus side, because it's a 3-sided shape. Find a side, add it to the other side, add it to the other side. So we just plug in the sides. Here we got 4, and we got 3, and we got 7. Notice that I did not add that 2.5 in there because that's not a side of a triangle. That is the height of the triangle. And when I add them up, I get 14, right? And that's all you do with area or with perimeter. You simply just take your take your sides, 12 plus 13.7 plus 4.9, add them up on a calculator, beep, boop, 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 beep. 30.6. I think you guys are getting it. You just simply add up the sides of the triangle. So 5.5, 4.5, 12. Check. There's the 3 sides of the triangle. Add them up. Scooby Dooby Doo, it's 22. And that would be the, and so if we're measuring the outside of a triangle and their units, let's say all those were feet, our answer would be 22 feet. It's not 22 squared feet because it's just a straight line. Area does squares, perimeter does a straight line. Okay? All right, so let's just fill in the blanks here. Triangles are what? They're half of a rectangle. And if they're half of a rectangle, that means the formula for the triangle is half of the formula for finding a rectangle. What was that area? How did we find area of a rectangle? Base times height. And what do we want to know about that? We want to know half of it. And that's why we cut it in half. Finding the height of the triangle means you find the blank between the base and the opposite angle. You find the right angle between the base and the opposite angle, which means you find that opposite angle, and draw a line straight down to the base, just like gravity take over. And to find the perimeter of a shape, all we do is add up all the side lengths. I think you're ready to solve the area and perimeter of triangles. You just got to be real careful to know which part of the triangle you're talking about. Remember the shift of length times width to base times height. All right. Do you guys have any idea why dragons sleep during the day? So they can fight knights. The knights with it and the knights with the dark. Whatevs. Good job, folks.